Okay, the floor is yours. Go ahead.
Okay, thank you, Piotr. Thank you for the invitation today. As you said, well, this is going to be about a very interdisciplinary approach to measure wealth and inequality. We'll use or introduce you a bit the technique of remote sensing and how can we complement other more conventional sources for our studies. So the title is Satellite Imagery for Social Data Science, and we'll use Poland and Spain as our case study for illustrative purposes, and because we're more familiar with the relevant sources. So basically, just a bit of background. The reason why we do this, it's good to have the whole picture sometimes, is, yeah, I think understanding population dynamics and socioeconomic changes are important to being able to implement public policies successfully, or to measure the impact of that policies, but also some infrastructures, or just to see how is a country or region or whatever area we are studying doing in terms of economic performance, but also inequality. Inequality is becoming more and more important element in every economy, and there are plenty of studies showing a high correlation between inequality and political subjectivities, in a way that when the tension, so there is a lot of social tension, a lot of social inequality, this can spread in many unpredictable directions. So the question is, we need to measure socioeconomic changes. And the reality is that for many countries, the sources we have, like censuses or surveys, are usually incomplete sources or just non-existent sources, particularly in the global south. Even though we complain in Europe or Spain and Poland that we lack of certain data, if we compare with the global south, we are in a good shape, actually. And that's why this field of satellite imagery is more inclined to study global south, because if you go to Africa, the sources, the statistical sources are really, really limited. But at the same time, we also need to complement our sources in Europe with these techniques, especially when we want to study the small scale, small geographies, municipalities, or even sub-municipalities. And especially we want to do a long-term time series analysis, because in Poland and Spain, we only have 2, 3, 4 years back data available. If we want to study the whole evolution of a country at the municipal level, where many socioeconomic dynamics are taking place, including inequality, because inequality has been proved to being more negative when it's at the local level. Because if you see that in your country, the inequality is growing because there's an elite in the capital that is having a lot of money, it's bothering you, but it's not so harmful. Because, but if you see your neighbor having a lot of money and with no particular merits compared to you, this is really harming the social cohesion. So this is what brings us here, to being able to complement all the sources we have, being able to do a long-term analysis. And yeah, this field of satellite Earth observations is very promising, not only nighttime lights, as we will see today, but in general, because we can, even though we need a lot of rigor in these methods, it also requires a lot of creativity, a lot of interdisciplinarity, because we can sort of classify the images, the pixels of an image during the daily time, not only nighttime, to measure poverty, to measure urbanization, etc., as I will show later on. So just keep in mind that this is what we call here nighttime light is NTL. And now we'll move a bit on to show you basically the structure of today's presentation. I want to make a brief introduction to Earth observation, just some insights of what does it mean, and for those who are not familiar with it. But then we'll narrow down to a particular field of nighttime lights and what's the state of the art. So basically what we know already, what we take for granted, or where the debates are right now. So then we can place our question properly. Then I want to emphasize which questions are we trying to address in this project, because, well, this is, I should say, this is an ongoing project, and today we will present we are happy to present the preliminary data, but we will have to dig actually more into the data we have. But yes, overall, the question is, are nighttime lights a good proxy of economy and equality at the local level? And well, then we'll see some methodological notes, what we are doing with which sources, which products, analysis techniques, etc. And then a couple of slides with the results related to the research question. And well, I can anticipate that, yeah, there is some good results, or especially for economic performance, and for inequality, there is some promising data, some conclusions and some references. All right, so remote sensing, it's basically, if you look at this picture on the right side, it's just capturing or data that is from the electromagnetic radiation, can be reflected, emitted, or backscattered from an object, can be a tree, can be a building, any geographical area. So we extract the properties of that objects. As I said before, this is very rigorous, but at the same time, it's very creative, because we can really measure poverty based on the reflection of buildings as well. Actually, some socioeconomic studies are using not the nighttime lights, but the reflection of the buildings during the day, with very good results. We can classify the roofs of walls and to put a label on what is a poor roof, and in a way that then we use artificial intelligence to classify the whole city into areas of socioeconomic standard. But the reality is this requires a lot of calibration, because we have clouds, we have many other effects that disrupt the observations. Well, more people, geoinformatics, and more people engaged in this satellite imagery are doing. The good thing is that this National Oceanic and Atmospheric Administration, which is a scientific agency basically devoted to meteorological studies, understanding the atmospheric conditions, etc. Usually they provide a very ready-to-use composites, a ready-to-use products. And that's why this field is becoming very popular, because you don't need to be an expert on satellite imagery to use it for more social science purposes. But it's important to bear in mind this NOAA, as it is popularly known, because it's the main source. There are many other sources, but this is the one we are actually using. And just this image, this animation, it's just reflecting this. NOAA has launched recently. It's going to launch a new satellite soon, which will improve the resolution. And it's just a couple of days ago they were doing some critical testing. You can find more on the internet about this. So, but the truth is that remote sensing is mostly used for in the field of environmental science. Many people is working on issues like classification of land use or measuring land use changes in order to, well, for instance, classify certain regions into agricultural lands and grasses, trees, etc. There are, for instance, very strong groups. What I used to be before in doing a postdoc in Copenhagen at the Faculty of Geography, people who is entirely dedicated to count, as simple as it sounds, all the trees in the world in order to, but also being able to measure the size of this, of the trees, and which is very important to being able to include certain emission capture that are not taking into account in the modeling of climate change, for instance. And very quite popular index, normalized difference vegetation index, which basically describes the difference between visible and near infrared reflectance of vegetation cover, and that can be used to measure the density of green areas, including in the cities. I think there is some study actually about also where using this index to see which areas of the city has more density of green, which could also, there is some studies also measuring how what's the correlation between the health of the green areas and the socioeconomic status of the neighborhoods. So that said, well, the logic of is basically we need training data using high resolution satellite imagery that allows to recognize the objects we want to measure. We can also go to field to double check what we are talking about. But in the end, once you are working on it, it's more about just clicking the classifying all the pixels you have in an image. As you can see in the right side image, every photo has a number of pixels, and each pixel receives a value. For us, it's going to be an economic related value, but it could be many others, could be some categorical value like being grass, being water, being urban, whatever. So once we have a training data, then this is when we can do a model to classify an entire country sometimes. In this case, for instance, you can see in the background, it was a map I was trying to do to detect all the invasive species in the northern Spain, which is called eucalyptus. So we zoom in we click on a pixel that we are sure it's eucalyptus, and then our software will recognize all of them all around. So yeah, this is the logic of remote sensing. But as I said, it's very creative. We could do the same for urban areas, to measuring the roofs, for instance, of the urban settlements, and try to classify them into high income households, medium income, low income, which of course requires a lot of qualitative understanding of the country, requires a lot of field work, and even some philosophical questions, right? What is poverty? How it is reflected in land, in the buildings, and the same with light, as we will see later. All right, but this is the nighttime light image of Warsaw from the 20 21. You can see it also is divided in pixels. It is
Kim,
afterwards.
sorry for interrupting, but can you turn off your camera? I think it will make the connection better.
Yeah,
Sorry.
sure.
Thank you.
Yeah. So basically, contrary to the previous map that I showed, here we don't measure categorical. We don't classify the pixels into categories, but rather every single pixel is going to receive a value, and this value correlates with the intensity of the light in this particular place. Depending on the product, we will see later, the resolution is going to be higher, meaning that good resolution will have a better representation of the object we want to measure. You will see later on what I'm talking about. So yeah, this is the logic behind these methods is that. So nighttime light, it's has been booming for the last 20 years, I could say. And the uses of this technique has expanded extraordinarily to urban expansion and population dynamics, tracking electricity consumption, estimating GDP, which is our focus on this project actually, but also poverty, looking at the less intensive illumination. You can also measure poverty, monitoring disasters, armed conflicts, and many other uses. And it's worth mentioning what can be considered the pioneer of this type of studies. It was Charles Rosky, University of Washington. In 1975, he did, well, if not the first, one of the first studies using nighttime lights to measure, in this case, population with a very high correlation based on R square. In this case, it was a Puget Sound area. And basically, by that time, this type of studies were very intensive, required a lot of computational resources. And that's why they were usually very site specific, right? So, but without taking into account that the urban can vary a lot from one region to another. But it's, yeah, I want to show you sort of timeline of nighttime lights, because we have in the 70s the U.S. Defense Meteorological Satellite Program, DMSP, which was terminated 9 years ago with a spatial resolution of 2.7. Based on this, there was a lot of site-specific studies, and only until the 90s when all these images were digitalized. This is exactly when new studies are more often and with a greater scale. It's worth mentioning the Sutton and et al. Study that they were able to aggregating the nighttime lights to states and counties. They also found a quite strong correlation between, in this case, it was income, it was population, state population, and nighttime lights intensity. So, but coming to our particular field in 2011, Ederson, which is a sort of benchmarking in this field, came up with a paper showing the high correlation between GDP and nighttime lights. And the paper was actually titled something like Bright Idea. So this was the kickoff of a boom of socioeconomic studies using this technique, especially in those places where you don't have censuses, you don't have other sources. But also on important data also was the launch of a new satellite, this visible infrared imaging radiometric suite, usually known as VIRS. It was launched in October 2011, and improves DMSP, the previous one, in terms of data availability and higher resolution. We have 1 kilometer spatial resolution, meaning that the pixel we see is measuring 1 kilometer side, 1 per kilometer per 1 kilometer. So there was a review of the literature a couple of years ago showing that this up to 150 studies in economics using NTL in just roughly 8 years as a proxy of GDP and or income. The problem is, as you see, we can use DMSP, which was the first data available, was terminated in 2013. And then we have VIRS starting in 2012. The problem is that they have different calibrations and they need to, we cannot use it for a time series altogether. But the good thing is that there are people also working in the harmonization of this two products. In a way, you can then understand, measure economic changes for Poland since the 90s up to date, which is really relevant, especially to measure the effects of the transition in the 90s. So with this in mind, yeah, we'll now look at the nighttime lights, the state of the art in this particular field. What we already know, yeah. So the basic, the debate is right now, it's around the capacity of this nighttime lights to predict economy beyond the country and regional level, because there is fair evidences that yes, we can measure the GDP at the country level, but there is still some debates around the capacity of this technique to measure at small geographies. And without going any farther, Gibson in 2021, Gibson is actually one of the top references in this field, and he sort of put into consideration the capacity of nighttime lights to measure economy at the local level, using the cases of Indonesia and I think South Africa and some other African country. And based on this critique to the technique, me and my colleagues were encouraged to do the same in Colombia. And we found that there was a very good correlation actually at the very local level, and including some rural areas. But we, at the same time, we dig it into the reasons why Gibson didn't find a correlation, because depending on the vegetation of the country, when there is the canopy is very dense, and the jungle in the Amazonian area, for instance, in Colombia, we also got very bad results, because obviously the nights, you cannot capture the nights that are when they have a vegetation as obstacling the path of the lights. So in the end, yeah, we can say that we can I think we can measure local changes with this technique, but with some exceptions. In this case, what we did was collecting data for GDP at the local level provided by the National Statistics Office. I look at the correlation with nighttime intensity aggregated to municipalities. And we run just a basic linear regression. We also run a panel regression to measure how the year variation in nights affects variation over time how it estimates the variation of GDP. But for simplicity reasons, I just showed this here. But we also find a good correlation using a panel regression, actually. If you want more details, you can just look at the references later on to see our paper on Colombia. More detail. Someone is muted, yeah. All right, so, yeah, so actually I think there is a quite agreement that the capacity of nighttime lights to predict economy across sections, across regions, across municipalities is much higher than time series. There is an overall agreement. We found that a good correlation also for time series, but generally it's assumed that this is it's more difficult to. So even though you take 2 separate years and you find correlation in both years, that's one thing. Another thing is to see a time series of nighttime lights and time series of the, for instance, the correlation, it's more uncertain. And in terms of inequality, the latest study we have, it was just published 1 year ago, and recently also within a special issue. And they found a positive correlation between Gini estimated with lights and Gini from official sources. Well, in this case, it was a survey, actually.
Shaquille, we cannot hear you. Are you there?
Hello?
Yeah, now we can hear you.
Oh yeah, how long have I been muted?
I don't know why.
I was just now, right? Maybe I hope.
For a moment, we didn't hear you. Okay,
All right.
are you back?
Yeah, hopefully not long.
No, we didn't hear the last comment on the Weidman.
Yeah, this, yes.
Okay.
Okay, well, there are several studies on inequality, and but usually at a regional level. And sub-regional level, we have this recent study from Weidman and Teunissen, which is promising, but at the same time, it's just they selected just a sample of qualities where they had available survey data. So basically, this is where we try to build on, right? Using a more systematic approach to measure the correlation between sort of nighttime lights, Gini, and Gini from official sources. So, yeah, the research question is, well, we have several research questions, but divided into two groups. First, economic activity, are NTL a good proxy of economic performance at the municipality level? Can yearly variation in luminosity predict yearly variation in economic activity at the municipality level? And then inequality, the same, basically. Cross-sectional and time series. But yeah, as I told you, this is an ongoing process, and today we'll present just basically the cross-sectional the data we were able to gather so far. how are we doing with time? It's okay. Yeah. So some methodological notes we have used for data sets, actually two, but with a urban layer to explore some improvements in the results. But basically, these are the two products I mentioned before, VIRS, yeah, annual, which is available for 2012 to the present, probably, yeah, 21st so far. The same composite, but masking the data for urban land. This is just a way to experiment, to explore if we get better results, removing, for instance, infrastructure that might disrupt the analysis, or even some lights like reflection of water that has nothing to do with economy, but also some infrastructures like, well, mines and motorways, and just to capture the lights from human settlements. A third data set with the harmonized data. This is particularly important because if we are able to validate this harmonization, then we will be in a good position to measure economy since the 90s. Otherwise, we will have to do it in two rounds, using first TMSP and then VIRS. And the same way, we masked this harmonized data set with a layer of urban land. Oops. So for the analysis, as I said before, we focused on cross-sectional regression with we ran a bivariate linear regression to test the ability of the selected data sets to predict regional domestic products across, well, this is just a copy paste, but it should be here, Poland and Spain. And we used 2018 just as a base year. And for Poland, we have municipalities in the end, and for Spain too. For computational resources reasons, we did a selection of municipalities, in this case for the autonomous community of Galicia. Dependent variables, we have, for Spain, we have quite good official sources on net average income per household should be here. Regional domestic product for Spanish municipalities, and Gini coefficients, all of them based on tax office from Spanish tax office. And for Poland, we have share of municipality budget in personal income taxes, corporate income taxes. Altogether, we'll have to explore separating it in the future, but also Gini coefficients for cities. And as independent variables, we have the sum of lights within municipalities. We also wanted to explore what happened if we, instead of the sum of lights, we measure the maximum value within these municipalities. And also on a NTL-based Gini coefficient and a standard deviation. We could also measure many other indexes of dispersion, statistical dispersion. In this case, we just focus on this too. So, well, this is the basic formula for the three dependent variables. Where we are trying to measure the unit of analysis here is municipalities, the intercept, coefficient for NTL, and the error term, the residuals. Yeah, just following the literature we'll use for estimating the strength of the correlations, we'll use the R square. So here comes the results. It's yeah. First of all, let's focus on the harmonized data. Overall, there is a the RDP, the regional domestic products. It's shows a high correlation in the case of Spain. When we sum up all the lights within a municipality, this correlates with official sources on RDP. In term for Poland, this yeah, we were discussing actually before joining for this Zoom. The income in Poland, we are taking into account both individual taxes, household taxes, and corporate taxes, and that's why we see that the sum of lights correlates with income for Poland, but not for Spain, or not so much for Spain. Probably because this tax or corporate taxes, maybe you can also give us some feedback. It's sort of measuring a bit the regional domestic product, since we are taking into account the companies, not only households. So the next step is for us is going to be to split them up, and just to focus on pure income per household or income per person. But anyway, the measure here is that you see that VIRS improves the results because the resolution is higher. But what we need to take from here is that whenever we add urban layer, the correlations are overall improving always. Especially, for instance, in the case of Spain, the sum of lights after masking the data with an urban layer, we double the correlation. So this is marking somehow the path to follow in the next steps. Another thing is, in the case of Spain, not in the case of Poland, because the reasons I said before, because we still need to play a bit more around with the data. But in the case of Spain, the maximum of lights, it seems to correlate quite well with income, but little with the regional domestic product. The contrary with sum of lights seems to correlate with domestic product, but not so much with income per household. So, but the best correlation is for using VIRS, which is the most recent product we have, and with the highest resolution, and with RDP, which you see in the right, on the bottom right side, is 0.897 R square, which is the numbers I actually got for Colombia, pretty much the same. And the same with Poland, also very good correlation for sum of lights and the urban layer. And here comes the trickiest part. The bad news is that we couldn't find a great correlation between lights, Gini, and Gini from official tax sources. As you can see, there is a significant correlation, but it is a big correlation. And the only promising thing is that when we add the urban layer, there is actually an improvement. We didn't estimate yet the Gini for Spain, but the standard deviation using the harmonized data is actually almost double after adding the urban layer. So this is the good news, is that if we try to mask what we have with better urban layers, because after all, this is a very basic urban layer, we can talk later about this. If we are able to mask our data with a layer of buildings, a good example is OpenStreetMap. You can download it from the internet, but there are much better from the German Agency of Space. We already requested this layer, and we believe that this correlation could improve from weak to moderate. And this is that's the good news. So bad results, but some promising signs. So basically, the data gathered shows that correlation between RDP and NTL get around the strength observed in previous studies at subregional level. As I said before, I found, yeah, we can say that we confirmed the data we collect, we found for Colombia, despite being very different geographies. Correlation is also high between income as measured by the share of municipality budget in personal income taxes and corporate income taxes. As I said before, our impression, our feeling is that if we divide these two sources, we'll probably find more correlation with corporate income taxes, which is more related to GDP, and probably lower to pure personal income taxes. So matching, getting more similar to the case of Spain. Yeah, correlation between NTL-based Gini and Gini coefficient from official sources is significant, but weak. And as said before, if we add better urban layers, we believe that the results can be better. So that's the work we have to do in the future. And but just to the problem, correlation might be low. It's basically, if we look at the meaning of resolution, usually we play with 1 kilometer resolution. We're using the latest product. Obviously, we are capturing the value for many houses within this pixel, and all these houses are receiving the same value. Regardless, within this pixel, there might be a lot of differences. Ideally, we should have a 30 meters resolution. In a way, we can capture the light from one specific house, which would equate pretty much income per household, the one we have in our in official sources. So this is what is somehow disrupting this type of analysis. But obviously, we can also improve in this sense if we add some variable measuring, taking into account the number of houses, the urban density of the cities, because there's probably a lot of differences between Spain and Poland. So yeah, that's the way out in the future also, to try to improve. Not mentioning the fact that some households are different floors, right? The buildings, some high buildings, they have different floors that we are not always measuring. Because that's another question we need to raise here, is a more qualitative, is what does it mean what does it mean light actually? It's really a reflection of our standard of living. This is a very anthropological question, because you may have very high income, but for you to your values makes you consume less light, and the other way around. So there are many questions to be answered for this technique. But just let me mention this study measuring socioeconomic segregation in Europe. And obviously the segregation, varies across cities. And as long as you have a high segregation, the nighttime lights, which tend to group these buildings, will be higher. But in the case of, also, if you notice, the black color is polarized, meaning that within these areas, you have either high income and low income people, families. And correct me if I'm wrong, but this should be around Mokotov, probably, right? I'm not sure if this is Mokotov. But other cities like Prague, the segregation, it's really different. So maybe including all these factors in our models, we could in the future come up with better correlations, better capacities to estimate economy and inequality. So that's another, I think, homework for the next steps for the future. And I don't know what time is it. Yeah, these are the references if you want to know. If you want to have a copy of the slides or something, just let me know. And more details about methodology and stuff everything is here. So thank you very much. Once again, thank you, Piotr, for the invitation. I'm looking forward to your questions and comments. Thank you.
Thank you, Shakin. That was great timing. Exactly, even it's exactly on time,
Really?
45 minutes. So I open the discussion. I don't see any questions in the chat. So if you wish to comment on the research, which we try to do, then we really appreciate any comments or questions which you might have.
Maybe one naive question I have about the feature extraction in the. Can you tell us the procedure of the feature extraction in your project? Is it happened by machine or happened by
yes,
human?
Yeah, I mean the extraction is we basically need to you have the image, which is a photo with pixels with values. Then you need to, in this case, I was using a GIS software in a way that you have you have a raster, right? Which is just the format you get when you download the data from the service, from the provider, which is the typical format you have of a photo. And this raster, you can convert it into points, which is a vector format. And these points have assigned a value. So it's just, well, you can do the same in RStudio, for instance. So it's quite a straightforward process. I think that the hard job is already done by the US satellite providers and other providers, because they need to calibrate all the data to remove the clouds and everything. So what we get in the end is just an image with a lot of millions of pixels receiving a value. In this case, they're reflecting the intensity of the lights. So it's just a question of having the right script, the right code to run it in your software.
So if I may add just one word, basically the data are in the form of a grid of pixels. So the whole globe is divided into pixels of a size of around 1 square kilometer, as Shakin mentioned before. And for each pixel covering the specific area, we have just one feature, right? The value of light or reflectance for that particular pixel. So there are no other features. And other features, we aggregate the data for particular areas, right? So if we take the municipality, we take all the pixels within this municipality, and based on the values of lights for a particular municipality, we calculate some metrics like the sum of lights, the maximum of lights, standard deviation of lights, Gini of lights, if you mean this as features. But we don't extract features. You may mention the daytime lights, which are pictures, which are also done from satellites. And in this case, of course, you extract pictures like green areas, houses, and so on. Here we purely work on the values of lights, which are supplied in a one-layer raster data. Okay, there is a question. Alexander is raising his hand. Alexander Bishopov, can you?
Yes. Hello, can you hear me?
Well, yes, we can hear you.
Great, well. Thank you. Welcome from Germany, but actually I'm from the University of Copenhagen, so a colleague of Hakim, and we will see soon each other. I'm looking forward to meet you in person. And just very briefly, Mark, during the Special Econometric Conference, I'm coming actually in one day to Warsaw, so would be very happy to meet anyone. My comment also in the context of the hacking and the work is that we try also to look about exactly remote sensing of social. So remote sensing on the human footprint, where there's been a lot of focuses. And one interesting thing is coming that exactly what Hakim mentioned, that there is quite a bit of the activities to develop the long-term time series. So if you see some interesting data sets, let's say looking at the structural change, also in Central Eastern Europe, Poland, neighboring countries, well, unfortunately, we can provide some insights on the situation in Ukraine. This primarily the data can be useful. And now there is also efforts and awareness among the scientists to push us community and to develop the new satellites going at the 300 meter and finer and finer. So we probably will witness more data sets are coming at finer resolution measuring nighttime light. So just kind of the insights that society is kind of noticing that it's really important. This is why this work is super important also from methodological perspective to show what can be done with the nighttime light data. Yeah, thank you.
Thank you for this comment. I cannot wait to meet you in Warsaw. Okay. Any other comments or questions?
Just one remark, yes. Following up with Alexander's words. Yeah, and I think this is very important because, as I said before, because all this, it's a way to validate a technique that can be extremely useful for other countries where there is no data at all, especially in the global south. Because after all, we can do something in Europe with data, official data. But as long as we improve the technique in the global north, then we can really use it for other purposes where there are a real lack of any kind of socioeconomic data, where the need is probably higher. So yeah, this is very important what we do. Yeah.
Okay, thank you. Any other comments or questions? The last chance to ask a question.
They can attend its time on Thursday, the conference.
Yeah, of course, all of you are invited to our conference in the Faculty of Economic Sciences on Thursday and Friday, the Spatial Econometric Association conference in our faculty. Well, Hakim will also present the results of our research. But if there are no further questions, then thank you very much for joining us. Thank you, Hakim, for presenting our results.
Thank you.
Of course, there's a long way to go. We analyzed just 1 year so far, but once the methodology is developed, we will extend this for sure to answer all these questions which you presented, not only related to just cross-sectional explanation of the phenomenon, but also trying to look on the dynamics between years. Yeah. So thank you very much once again. Let me stop recording.